Assalamualaikum and hello everyone. We are groups of students from 6A to B will present our road safety audit for ECG 563. Our selected location is curved and hilly road segment that connects Melati College and Faculty Building, resulting in frequent pedestrian movements. Zebra crossing is located along the curve, which introduce significant safety concerns due to reduced visibility and vehicle speed behavior. This combination of horizontal curvature, vertical gradient, and pedestrian crossing increases conflict risk between vehicles and pedestrians. Therefore, this location was selected due to its high exposure to vulnerable road users, particularly students.
From initial site observation, vehicles were observed approaching the zebra crossing at relatively high speed while negotiating the curve and the slope. At curve and hilly section, drivers experience limited stopping sight distance, especially when the zebra crossing is positioned within the curve. Road safety literature highlights that pedestrian crossings located on curve significantly increase crash risk due to delayed driver perception. Guidelines such as JKR Road Safety Audit recommend that pedestrian crossings be located where visibility and speed control are adequate. However, at this location, the existing conditions may not fully satisfy this safety requirement.
To evaluate whether vehicle speeds are appropriate for this pedestrian crossing, a spot speed study was selected. Speed behavior is a critical factor affecting pedestrian safety, particularly at zebra crossings on curved and sloping roads. Higher operation speeds reduce drivers' ability to stop in time for pedestrians, increasing the severity of potential collisions. Therefore, the speed study provides quantitative evidence to justify the safety risk at this location.
The speed study was conducted using the spot speed method. A measured distance of 2,000 meters was marked before the zebra crossing. The time taken for vehicles to travel the distance was recorded using radar gun. Vehicle speed was calculated using the formula speed equals distance divided by time. All data collection was conducted while maintaining safe distance from traffic and wearing appropriate safety equipment.
The average vehicle speed recorded at this location was 39.15 km per hour based on the time mean speed analysis. The 85 percentile speed was 47.15 km per hour, which reflects the upper range of operating speeds observed. This value was compared with the recommended speed limit for pedestrian crossing zones under GKR standards. The results indicate that the prevailing operation speed exceeds the recommended safe thresholds near zebra crossings, especially given the curve and downhill alignment. This condition significantly increased risk to pedestrian crossing between the college and faculty buildings, highlighting the urgent need to speed management and visibility improvements.
At curve and downhill section, braking distance increased due to reduced tire road friction and gravitational effect. When combined with pedestrian crossing, higher speeds greatly reduce drivers' reaction time to unexpected collisions. Pedestrians, especially students, may assume vehicles will stop at zebra crossing, increasing vulnerability. This mismatch between pedestrian expectation and driver behavior creates a serious safety hazard.
For the purpose integration model, solution of speed reduction before zebra crossing. Based on the spot speed study, the vehicles were found to exceed the safe speed threshold. Therefore, introducing a reduced speed limit zone before the zebra crossing is essential. This ensures drivers have sufficient stopping sight distance even along the curve and downhill section.
Number 2 is advanced pedestrian and curve warning signs. One of the main issues is delayed driver perception because the crossing is located on a curve. Installing advanced warning signs such as pedestrian crossing ahead, sharp curve, and steep gradient will provide early alerts. With these warnings, drivers are more likely to reduce speed before reaching the crossing.
Solution number 3 is to enhance the zebra crossing visibility. Literature shows that the pedestrian crossing on curves are high risk due to poor visibility. Therefore, zebra crossing markings should be upgraded with reflective paint and flashing beacons, raising a risk crossing
platforms can further improve pedestrian visibility and physically force vehicles to slow down.
A solution for physical speed control measures. Since operating speeds were recorded above safe levels, physical measures such as rumble strips or speed tables should be introduced to enforce speed reduction. Guardrails can also be installed to channel pedestrians toward the designated crossing point, minimizing random conflicts with vehicles.
In conclusion, this road segment presents a high safety risk due to the combination of curve geometry, hilly alignment and pedestrian crossing. The speed study confirms that existing vehicle speeds may not be suitable for this environment. Engineering analysis and standard comparison justify the need for speed management and pedestrian safety measures. The proposed mitigations are practical, cost-effective and suitable for campus implementation. Thank you for watching and for your attention. This concludes our road safety audit for ECG 5